Thanks for joining us for the interview portion of the Data Speaks competition created in partnership with RFG 2018 and Sequent. I'm Nicole Doucette, a science communications specialist with Sequent, and I'm joined today by Sterling from the University of British Columbia.
Thanks for the invite.
Yeah, of course. Okay, Sterling, your original abstract title was Stabilizing Mine Waste and Reducing Greenhouse Gas Emissions by Targeting Labile Magnesium in Tailings for Accelerated Carbon Mineralization.
Yeah, that was a mouthful, so I made a better one.
Okay, so what is this revised
The new one is Mining for the Environment, a how-to guide to mitigate climate change by mining nickel.
Yes, I can understand that one. So what question are you trying to answer?
So the question I'm trying to answer is, what is the most economically viable way for nickel mines to not only become carbon neutral, but actually become carbon negative, where they're actually absorbing more carbon dioxide from the atmosphere than they're producing, so they're actually mitigating climate change.
Wow.
To do this, I'm studying a technology called carbon capture. In the past, this technology has been too energy intensive and therefore far too expensive for these mining companies to accept it and use it at their mine sites. So what we're doing is we've proposed a few methods to drastically reduce the energy requirements for this carbon capture process, but we need to take it one step further and think of, okay, what are some additional economic benefits that this technology can provide to the mine site so that these mining companies will be really keen to implement this technology because they can save money even if they're not subject to a carbon tax.
Great. And so what concept does someone need to know to understand your research?
So they need to understand that we mine nickel from rocks that contain usually less than 1% nickel by mass. And the rest of this rock, you have to actually pulverize all of the rock to recover the nickel. So you can imagine these nickel mines produce an enormous volume of pulverized rock waste. And some of this waste contains minerals that will naturally react with carbon dioxide, even from the atmosphere. And this chemical reaction will turn that carbon dioxide gas into limestone. So what we're doing is we want to target these really reactive minerals because then you don't have to supply a lot of energy to make them react. And how this can save the mine money is the reaction product, the limestone. It acts as a cement that stabilizes their waste products. So not only is this reducing the risk of the waste spilling out into the environment, but since this waste is now self-stabilizing after it's absorbed CO2, maybe they don't need to spend hundreds of millions of dollars to build a big containment facility for their waste products.
Wow. So what role does data play in your research?
So in order for the mine waste to quickly and cheaply absorb CO2, they need to contain a very special type of mineral. And finding this mineral is kind of like hunting for buried treasure. But luckily, the mining companies, they already have an enormous volume of data that we can use to help find out where these really reactive minerals that are really good at absorbing CO2, where they're hiding. And they have all this data because when they're hunting for their own buried treasure, in this case a nickel deposit, they're collecting all of this data. So all I have to do is really go to these mining companies and say, hey, give me your data. And I take that data, which contains information about the chemistry of the rocks, and I go back to my computer and I'm going to make some mathematical predictions about, okay, where are these really reactive minerals located, so I can help them manage their mine waste to not only absorb CO2 and help mitigate climate change, but potentially reduce their construction costs because now their waste is self-stabilizing.
Great. And so why is it important for you to share your data and your research?
So in order for this technology to have a significant impact, it's not just about having one carbon neutral mine or even one carbon negative mine. It needs to be widely implemented. So we need to get this word out that we should be looking for mines that contain these awesome minerals that are great at absorbing CO2 so that our mines can actually mitigate climate change by absorbing CO2. And ultimately, this technology will probably be a stepping stone for more advanced technologies that can have an even greater impact on mitigating climate change.
Great. Thanks for joining us today,
Thank you.
Sterling. Of course. Once again, this is the Data Speaks competition at RFG 2018, created in partnership with Sequent. You can watch the videos on YouTube or Twitter, #CDataSpeak.